Okay, so here's 57 and 58. Anytime you have an analysis problem, we're going to use the products to determine the grams of elements in each thing that were originally in my substance, okay? And so 1244s, what do we call 1244s? What is that? Okay, the ratio, which is the mass percent, okay? So the exact same thing. It's the ratio of carbon to CO2, which we call the mass percent. So we're doing the percent composition. So if a simple problem said, you know, what is the mass of carbon in a 0.403 gram sample of CO2, you would just do this section right here, okay? That's the percent composition. I think we did some of those at the very beginning. All right, so, but then we get grams, but this is always a mole ratio, so we're taking grams to moles, so it comes out to 0.00916 moles. Do the same thing, this is the percent hydrogen in water times this, so you get this many grams of hydrogen. Now again, a common mistake is to try to divide by 2 here, because you think H2, but hydrogen in a compound is not necessarily going to be a 2. So you need to always divide by grams per 1 mole. Okay, so divide by the 1, you get moles of hydrogen, and then oxygen, you just subtract. We know it's all this, subtract those 2, okay? So you get grams of oxygen, and then go here. Now, what's the next step after we have this moles? Divide by the smallest. Okay, so we divide by the smallest, got the 1 to 8 to 4, so the empirical formula is C4H8O, but the molecular mass is 144. You find the empirical formula mass, divide it in, it's 2, therefore the molecular formula is twice the empirical formula. It's pretty much that. No matter what you do, it's going to be that type of problem. Okay, so 58 is exactly the same. Okay. Except, what happens when you divide through? Thank you. What happens when you divide through by the smallest one? You get this 1.5. You cannot round that to 1 or to 2. What's the rule? How close do we have to be? Like 0.05, okay, within a whole number. Okay, so this could have come out to 1.95 and we could have gone to 2. 1.05 we could have gone to 1. But anytime it's more than that, we look for the common fraction. Since 0.5 common fraction is 0.5 common fraction is 1 half. We know we have to multiply by 2 to get to a whole number, but if we multiply this by 2, got to multiply all the other ones by 2 to keep the same ratio. So the ratio turns out to be 3 to 4 to 2, so that's my empirical formula. And is that all it's asked for? Just the empirical formula on this one. Okay? So, pay attention, know that. Again, if it doesn't work out. Now, this could have come out to 1.49, 1.48. That's still going to be 0.5. If it comes out to 1.32, 33, 34, that's still close enough to 1.3. Maybe, you know, you can pretty much take it just to the 1 sig fig, and that'll give you your fraction. Because that's going to be just rounding, you know, and not getting the exact perfect answers. All right, so 57 and 58 are going to be on the test Friday, tomorrow. Okay? The next ones are not. Okay? The next ones are not. So just this was good practice, but then all the stoichiometry stuff that we did, you know, is not going to be on there. Now, I know like on number 67, it combined all of the dimensional analysis and converting units and all of that. So that doesn't mean you get to forget everything as we move forward. It just means that you're not going to be responsible for stoichiometry on the test. Okay? Any questions at all about what you need to know for tomorrow?
So these are called combustion problems?
Yes, combustion or analysis. Sometimes analysis by combustion. Okay? I call them combustion problems because you're burning. And again, sometimes they have nitrogen instead of hydrogen, or pardon me, instead of oxygen, they say how much nitrogen, or they do chlorine, but you do it all the same way. 2 out of the 3 you're gonna be able to figure out with percent composition, third one by subtraction.
So what's the format of the test?
Multiple choice, free response, problems.
Okay.
Are we gonna have like both periods to do it after
Yeah,
we start?
that's what I'm saying, if we start at 8:30, we'll just probably use both the whole rest of the time, so you guys will have 8:30 to 10, basically an hour and a half, so. All right, so we're comfortable on that, so you got the chapter 1 PowerPoint, chapter 2 PowerPoint, and remember, chapter 2, we only go up to naming, I think I said slide 39 on a video or on a handout. You don't have to do any of the naming in chapter 2. And then it's just all of this stuff is in the first part of chapter 3, the empirical molecular formula and percent composition. Okay? All right, well, let's look at stoichiometry then. So now let's take some time and put the rest of the problems on the board, okay? Rather than me going through them. Okay, so we did 58, 59, then we do 3 more? Okay? All right, so Ben, you get to do the first one. Who wants to do, I would say, does anybody want to volunteer to do 67?
No.
67, that's you'll do the next one?
Yeah, I'll do the
Okay. What are my numbers? What are the next?
65.
61, so you're doing 61, you're doing 65. Somebody wants to do 67? You can try. That's all you can do. And you have to erase the board completely, otherwise it's distracting. And again, those of you at home, fast forward through all this part and just get to the final answer. I wish I could pause the video, but with iPhone you can't pause. All right, now, do we see all those blue marks? That's you gotta erase the smudges. Yeah, you're like me, you like it totally clean.
Yeah.
Yeah. All right, there we go. So we did a good job of erasing the previous work. Ben's got his spotless. That's good. You gotta pass eraser school. Yeah, Anna, you could be here for 15 minutes. Putting this one up there.
My arm's gonna start hurting.
I've had to fight through 3 shoulder surgeries and raising it up and trying to write. Before you get going too far. I don't know if it's balanced, ends up being balanced right or not, but aluminum is +3. Sulfide is -2, so what's the formula of aluminum sulfide? This is +3, that's -2. Right, we're just gonna crisscross. Okay, now, that gives you 4 aluminums there. You're only gonna have 2, that's gonna mess up your balancing. So everything, all your other formulas are right. Okay, so, you're gonna have a 2 here. Okay. That's gonna, you have 3, you're gonna have a 3. So do the ones that are only in one place, hydrogen and oxygen, are a little bit more complicated. I know I have to have a 3 here. ones that are only single, you know, since oxygen is only here and there, I know I have 6, the hydrogen, how to work out. But always balance your charge running formulas. Okay, so the only thing that's gonna change now is your ratio. Now this is still gonna be, oh no, that's gonna be more different too. So, we'll just keep working it together. Sure. I'll help you out. 27 times 2 plus 32.09 times 3.
What was that?
32.09 times 3. Okay, as Paul's finishing up, do we all agree on 61? Okay, so we have the balanced equation, and we have 0.3 moles of sodium silicate, and then 8/1 to go to moles, so that's just the moles to moles, okay? So again, remember, we talked about mass to moles to moles to mass. That's the ultimate roadmap. You just need to know where am I starting, where I'm going. So this is just moles to moles, so I only gotta do the one step of the mole ratio, the balanced equation. The next one wants to go moles to grams, so you have 3 steps, you know, or three different terms, okay? And the 2/8 again is the mole ratio from the balanced equation. What's the 41.99?
Grams of sodium chloride.
Okay, what do we, the grams of, what do we call that, grams per mole, what's the term? The molar mass, okay? So that's the molar mass of sodium fluoride, okay? You're right in what you said, it's the grams per 1 mole, but the term for that is molar mass, okay? And then lastly, 0.8, and I'll let you guys take a break here in a second, let's just finish going over these and then we'll take a break, okay? So, lastly, it's a mass to moles to mass problem where you just do the whole kit and caboodle. All right, let's come over here. 67. Now, this one was a challenge. Because when you read 67, C especially, 67C says how many grams of sodium nitride are required to produce 10 square feet of nitrogen gas, about the size of an automobile airbag. So this is kind of talking about airbags and how they fill up, okay? So you have 10 square feet. Well, when we're doing stoichiometry, it's grams to moles to moles to grams. It's cubic feet, isn't it?
Oh, okay,
Yeah, it's cubic feet. I don't have my glasses on, so
Okay.
it's cubic feet, because it's the volume, it's the volume, okay? But if we're gonna do a stoichiometry problem, we need to have the mass, okay? So the whole first part of this problem is nothing more, this whole thing right here is all converting to grams. Okay? So this is the challenge. This is kind of a flashback to what we took the quiz on and that type of stuff, of being able to do this. And here's a very important thing, and you did it well, that a cubic centimeter and a milliliter are exactly the same. Therefore, if you have this many cubic centimeters, you can just use the cubic centimeters, 1,000 per liter, rather than the milliliters. You don't have to show a one-to-one, conversion factor on that. So all of this, and then once you get all of that, this part just gets me the volume. All of this is for V. And then this is times D, the density. So then volume times density gives you the mass. So if you were to stop right there, you get the mass of was it nitrogen gas, right? Now, once you have that, then it's just going to be just like these, stoichiometry, grams to moles to moles to grams, and solving it out. So the whole trick on this part is knowing, again, they give you the density, they give you a volume in cubic feet, but in order to be able to do stoichiometry, I really needed the mass, or a way to convert to moles. And we don't have a way to convert volume to moles. Okay? We're good with that? That was a good one. Okay, and then 65. Okay? Just when we're writing our equations, this one required you to write the balanced equation. Okay? Most of the time you don't have to write the balanced equation. They don't ask you for that on the AP test, they give it to you. Okay, which is why we're not going to spend a lot of time talking about that. But the key is you always balance the charge. Since aluminum's +3 and sulfide's -2, we want to crisscross +6, -6, so everything equals 0. So the formula is going to be Al2S3. Obviously we know water did a good job here. Aluminum is +3, oxygen is -1, so we're going to bring the 3 down. Hydrogen is +1, sulfur is -2, so you brought the 2 down for that one, okay? Step one of any balanced equation, step one of any stoichiometry problem is having a balanced equation.
For the OH, like that's hydroxide, do you just have to memorize that it's -1, or is
Yeah.
there a way to figure it out?
There you go, you just know it.
You work it out.
Yeah, for right now you have the chart. We'll use it enough to where you're just gonna know. Okay? Now, pretty much we know oxygen is -2, based on its position on the periodic table. Hydrogen we know is +1, so a +1 and a -2 is gonna end up at a -1. So if you just, yes, technically we can figure it out from that. Best just to, common ones, nitrate, sulfate, hydroxide, acetate, there's gonna be like 10 common ions we should just pretty much be real familiar with. You won't have to memorize them until April. Then I'm gonna give you in April, right before the test, the AP test, I'm gonna give you a stuff to memorize quiz. And I will have a list of things that you just need to know. Okay? All right, so I just wanted to point out we have to have a balanced equation, and when we're writing that, the first thing is you balance charge first, and then we balance atoms last with coefficients. Okay? And then the rest of that, this is just grams to moles, and then moles to moles. This is just breaking the thing down into 3 steps, rather than doing it in one big long step. Okay? But AP likes to do it this way. Okay? To where then you just gotta know what you're finding on each thing.
So for AP stuff, we need to break it down?
No, what I'm just saying is they'll ask question A, how many moles given this, how many moles would it be? And then they go to part B, how many, moles of this, or, they just do it. Ask you the question in steps rather than just the one big old long problem. So you just need to know what you're finding at each step. Okay? All right, you get to take a break because we missed our break, so, I'm trying to be director and co-star, and we're gonna have